The year is 1971. The Vietnam War is in full swing, the Pentagon Papers are printed, and the fronts between East and West in Europe enter a phase of relative peace and negotiation. The Pittsburgh Pirates manage a surprise victory in the Baseball World Series, and in Europe, Leeds United win the Intercity Fairs Cup in football, none of which has anything to do with this video. On the other side of the globe, in Asia, things were beginning to shape up. The post-war economic boom rapidly accelerated Japan's economy. Electronics manufacturers and other industrial companies sprung up like trees. The Victor Company of Japan, known as JVC in the Western world, disappointed but encouraged by its failure to bring earlier video recording technology to the home market, set out to create a media format that would cement video recording as a central piece of technology in the common household. This format is called Video Home System, or VHS. JVC licensed their format openly and encouraged many manufacturers to partake in this endeavor, such as Hitachi, Toshiba and Mitsubishi. On September 9th, 1976, the world's first VHS recorder, the HR3300, was released to the Japanese market. JVC's other major player in the VHS game, Matsushita Electric, was eager to join. They released the NV-8600 and soon later, in a stroke of genius, cooperated with American brands such as RCA and Magnavox to manufacture devices for the North American home market. These brands were regarded as reputable, reliable, safe choices for household appliances, which aided the acceptance of the new technology. The video cassette recorder became a staple of the average American middle-class home by the 1980s. The other major region of the First World was still left in the dark as late as 1978. The phase alternating line or PAL color system, commonly used in Europe, was not interchangeable with the Japanese and American NTSC format and required adaptation of the electronic color processing and servo circuits to bring the format to these regions. But finally, 1.5 years after the introduction of VHS, JVC and Matsushita, now operating under the name of PANASONIC, were ready to release their PAL machines. The PAL version of the world's first VCR, the HR3300E, and the NV-8600E, a slightly reworked version of Panasonic's first model, the NV-8800. And today we'll take a look at the latter. This is the Panasonic NV-8600E. Panasonic's first PAL VHS recorder, introduced in December of 1978. As expected from a first-gen machine, a top loader with piano keys. It's a humble machine, pragmatic, heavy, with literally zero special features. You can play and record standard play VHS tapes, and that's about it. No SVHS, no hi-fi stereo, no LP, no still frames. However, it impresses with its stature, the robust build and the fighting weight of 17 kilograms. But can we make it perform? Just a heads up here, I originally got this machine in late 2021 and back then I live streamed the first couple of hours of troubleshooting and repairing on Twitch. Unfortunately, I lost the recordings and the original broadcasts are no longer on Twitch. Here's what was wrong with the machine when I first got it. The audio was very wobbly, the picture was jittering horizontally quite a lot. A lot of wow and flutter. You see how wobbly that audio is? Servo lock issues and own recordings looking really terrible. There we go. Ah, the record quality is so bad. And when the machine was cold and you started to record, then the picture would be mixed in with what was previously on the tape, which indicated that the erase head wasn't doing what it should be. And since these problems were worse when the machine was cold, naturally I assumed that electrolytic capacitors were to blame, which wouldn't be that uncommon on a machine that's 43 years old, to be honest. Wow, look at that. Here's the inside of the machine. Oh, there's a motor here with a date code on it. 17th August 1978. So this is a unit made in 1978. The belts are in exceptional condition. Look at that. Look at all the capacitors though. How much do you want to bet that like half of those are bad, have leaked? Ah yeah, look, I can already see that there's a bit of a... Yeah, there you go. There's a couple of nasty spots here. And that one's decidedly leaked. Also has a green leg on it. There's another one. Yeah, we'll have a lot of these, and I think you gotta recap the whole thing. There we go. Ugh, nasty. Nasty. I then tried to find the head amplifier because bad capacitors in that circuit will cause picture problems much like the ones I've seen. As I suspected, the head amplifier module is on the back of the machine. It's mounted like so, and to get to the actual components on this board, you have to undo two shielding plates. Here's one for the bottom, here's the one from the top. Problematic stuff here. What do we see? We see leaks upon leaks upon leaks. And upon further inspection, it was basically deemed necessary to replace all capacitors in this machine because pretty much most of them that I had inspected had visibly leaked or other problems. And that looked something like this. Mind you, this was just a work in progress photograph. So after replacing all the capacitors, I basically decided to just do basic measurements, basic adjustments, you know, tape path and video level and so on and so forth, and then call it a day because I thought I wasn't going to use this for much more as like a museum piece, you know, put it in a shelf, make it look nice, and that's about it. So I didn't really care about a few things being off here and there, you know. Fast forward to a few weeks ago, I obtained an Atari 2600 with some games and I wanted to test it. Now it only has an RF output and I thought, why not use a time appropriate piece to try it, you know? And that's when I noticed a few things wrong with it and I decided to actually do a proper restoration and calibration on this machine. So here goes. First of all, I'm going to show my original alignment of the tape path because I had it nicely set up with the oscilloscope view and the service manual on the side from my stream. There we go, tracking control to the center position. Now, it's not a terrible result, but it definitely could be a lot better. So let's take a good look at the right hand side, which is getting flat a bit too soon. How about that? There you go, this looks a lot better. Now let's check the left hand side. See, that's no good. You don't see that on the picture for some reason, but definitely what you want is just a nice flat envelope. And that one's much better. Now I thought my tape path alignment was done at this point, but boy was I wrong. More on that later. Some slight mechanical restoration was carried out, regreasing some of the moving parts like the rails for the guideposts, as well as the loading motor and all the bits and pieces connected to that. There's a problem where if I press fast forward, the unit won't let me go into rewind or play immediately. And then I can't press the rewind button. Oh, look at that. That's slow. Can't press it now if I force that back. Ha! So that might have something to do with that. Yeah, all of this grease seems to have dried up, causing the mechanism to move very slowly. I'm gonna fix that. Man, some grease gets you a long way, look at that. I mean, it doesn't look very nice, but definitely nice action. I also shortened this spring because it was very, very tired. But as you can see, now it springs into action. Ha! Oh no! I was just about to finish up and I noticed that the machine stopped playing after 1 second, and I managed to get this belt off of this stupid wheel over there, and now I have to get it back on. I have no idea how the hell I can do that from here. All good now. Now we get to when I revisited the machine this year to test my Atari. In addition to the tuner problem that I mentioned, I noticed that there were intermittent dropouts accompanied with noise coming from the machine. I don't mean from the audio, from the machine. I managed to catch it on video. The dropouts are hard to see, but take a listen. What actually happened was that the loading motor started turning intermittently. Very, very annoying. This is the transport block diagram. It's the block diagram for the section of the circuit that, among other things, controls the loading motor, and it's an absolute mess. You can see that loading completion and unloading completion, those signals are involved. They originally come from a switch, and the whole thing is driven by a 19-volt supply that's unregulated. This is the actual schematic of the thing, and to this day I have not yet understood what the hell goes on here. My understanding of electronics just isn't sufficient. So this problem almost drove me insane. I was scoping the points that I marked in this block diagram for hours, and you know, eventually it started triggering, and it triggered a lot. Like, there was a phase where it was just happening all the time, and I thought this would give me really good results. I mean, it's having a firework, as you can see. However, this was really not anything conclusive. I couldn't really make out anything, and tracing anything was hard. I scoped other signals too, and I was ready to give up until I ended up with a capture that looked like this. As you can see, the base of Q609 has a really bad ripple, and the amplitude of the ripple is almost as bad as the amplitude of the signal itself. So this is obviously not good. I showed this to George, and he noticed that it took 20 milliseconds for that ripple to cycle once. We're in 10 milliseconds per division, and it takes 2 divisions. And that's 50 Hertz. Where do we find 50 Hertz? In the power supply. But if the power supply was to blame, or somehow a capacitor dried up even though I replaced them, we would have a 100 Hertz ripple here. It's 50 Hertz, which nudged George in a direction I would have never even figured out. See, this is why you gotta have friends that are smarter than you. He told me to check out the diodes in the rectifier. Remember how all of this is fed from 19 volts. And this 19 volts is an unregulated supply. So what we're seeing is pretty much directly what comes out of the rectifier. So let's take a look at the rectifier circuit and see what we can find. This is the schematic diagram for the power supply circuit in this machine. And this is where the 19 volt supply is actually created. It's a very simple linear setup. It's a full wave bridge rectifier with one double diode with a common cathode and one with a common anode respectively, followed by a huge filter capacitor of 2200 microfarads. So what could possibly go wrong there? I scoped the outputs of the power supply when the machine was doing nothing and when the motor was moving, and it seemed fine. And then George had another brilliant idea, which was to test the power supply in an isolated setting with the filter capacitor removed and a dummy load in its place. And this is what it looked like. I put my scope probe on the output and I couldn't believe what I saw. One half of the sine wave from the AC input had about 5 volts less amplitude than the other. I have never seen anything like this, and I probably won't again. And yeah, pretty clear case of a bad rectifier diode. I didn't have matching pairs at hand to replace the old ones, so I just replaced both pairs with a full wave bridge rectifier that I found in other equipment that I salvaged. And after doing that, this is what the wave looked like, and the machine hasn't acted up since then. So I mentioned before that I thought I was done with mechanical adjustments when I actually wasn't, because I noticed that there were some inconsistencies with the RF envelope after I got the machine out again. And here's how I troubleshooted that. So with this, I'm trying to adjust the height of this guide right there. Over there, that one.
but I can't really seem to get it without any tape creasing. So as you can see right now, it's creasing the tape over there. See, there we go. Now there's no creasing, but the signal is crappy. But when I push the pulley a little bit back, the signal improves dramatically. And I have no idea how one would go about fixing that. There's no creasing here either, or here for that matter. So everything here is perfectly flat. I just don't know what to do, man. So I finally got it into a spot where moving it around would put it just right. If I touch this, it no longer improves the signal at all. And what I did to achieve this was the base that the guidepost pushes against, I moved it ever so slightly. You can see where the original positioning was.
Please don't ever do this unless you're really desperate like I am. You can really mess up your tape path, and I almost did, and I took a long time to actually get it to a point where it was working properly. So please, this really is a last resort sort of fix.
But I've managed to fiddle it around just right so that the tape path is perfect. So now we got absolutely zero creasing on this side, and the other side doesn't crease either over there. And I have a nice envelope throughout the thing without any movements impacting it. I think I'm happy with that.
I will play my color bar tape on this machine and see where the playback is going. Looking at it, I do believe that the picture is a bit less bright than it should be. And we can verify that here very quickly by generating color bar pattern on this test signal generator. So that's the capture signal. Here's the other signal. So there's a bit of a discrepancy in brightness, definitely. Because the white should be like really white. Take it to the luminance adjustment, the video level adjustment. You know what, the weird thing I notice is the lower I put it, the wider the white becomes, but I know that the amplitude just isn't right. So this is like minimum. You can see the white is nice and bright, but there's lots of noise in it because it's like overcompensating a lot. So for now I will adjust playback chroma to 0 because then we can adjust the luma a bit better. PB chroma will be set to 0 for now. This is as far as I get the video level to go. It's supposed to be 2 volts peak to peak for the luminance part, yeah? And as far as I get the signal to go, without if I max out the potentiometer to increase the video level, that first bar is completely squashed, right? And we're still not even reaching 2 volts peak to peak, so something is a bit wonky here, yeah? So no matter how bright I make the signal, it just gets clamped down. So I tried bridging R373, I tried bridging R374, and what I notice is that everything gets crushed down pretty significantly. So what I think I should do is at the filter stage here, if I increase the video level to a certain point, crushing going on here. The next point is to check after C359 if that is still the case. Now when I increase it here, it also increases on the scope, so that's okay. And we shall see on pin 24 what the signal looks like. Nope, no problem here either. Okay, next point. Pin 25. Nope, no problem there either. The signal that comes out of pin 1 is the signal that actually is the finalized thing. Oh, whoops, pin 2, sorry, pin 2 is the actual output. My bad. So pin 2 looks like this. This is where the clamping happens. Okay, so this is again the luminance processing block diagram, and here's the problem. IC302 is some specialized VTR thing. The main video processor IC is where most of the magic of the video decoding happens. Starts here with the video heads at RF in and ends here at pin 2, which is the video output. The video signal coming in from pin 4, which is the E to E signal, you know, the regular video input, that's displayed fine, so there is no problem. But the video signal going in on pin 27 is also fine, which means that the problem is between pin 27 and pin 2, which means it's inside the chip and it means that we cannot fix it. And going to the schematic itself, the reason why I'm so sure is, look, the signal goes into pin 27 and it never leaves the chip again before going out of pin 2. This is the problem. And I checked all the DC offsets as well, the last thing I could think of that could possibly cause any problems, and they were all correct. So the only conclusion is that this chip is bad. AN6321, I don't know if I can even find a replacement for that. I guess if the video goes on now, you'll know that I did find one, but I'll only be smart in a couple of days. So, yeah, wish me luck. Yay, eBay! For 10 bucks plus a bit of shipping, I actually found a new chip. So, will this be a happy ending? Let's find out.
So this is that video processor. It's labeled as an AN6321 in the service manual. I found a shop that carries new old stock of this chip and it just arrived. It's definitely not used, but it is pretty crusty. Ugh. Look at that. I hope it's still good. I'll put it in and see if that fixes anything.
Right, so I'm ready to test this machine now. So let's give it a shot. Whoa! That is a lot brighter than it was previously. And look, it's not clamped anymore. I can move it. I can move the video level up and down, and it's not clamping. Let's adjust it to what it's supposed to be. Now, since the first bar has a bit of an edge rising problem, we'll make it a bit more than 2 volts peak to peak. So this should be fine. Put in a bit of chroma. I need to adjust this properly. That is a really bright and juicy picture. After 43 years of service, this thing is allowed to have a few bits and pieces wrong. So with that problem out of the way, I was finally able to do the playback, chroma and luma level adjustments. And this is what I ended up with. It looks pretty well to me. So what I'm trying to do here is adjust the white clip and dark clip adjustments because I figured that the waveform just didn't look right when compared to the diagrams in the service manual, and that is an adjustment that you have to get right for recordings to look decent. I'm guessing this is done to improve edge performance or something in the record circuit, but I don't know. And obviously after messing with all the pots, God knows when, and also with the new luminance processor chip in place, these adjustments had to be, you know, checked anyway. So, like, as you can see here, this is an absolute mess. The two diagrams differ from each other in quite a lot of ways, and it's just really unclear. And their test pattern generator has a white peak section in the middle, whereas the white bar on mine is full white. You know, those are all just things that get in the way. So this is what I figured matched the service manual the closest, and this is what my final adjustment ended up being. So did that fix our recording? Nope, not really. After all that's happened, I figured it would probably be a good idea to adjust the record current again, just to make sure. This is the instructions that the service manual gives you, and it tells you to connect your oscilloscope between TP504 and TP502. These are both on the head amplifier board. They expect you, and rightfully so, to connect the machine to mains using an isolation transformer. Else you'd short one of the terminals to actual chassis ground, you know? So any reading you get here by connecting your scope ground to TP502 is not gonna be what you're adjusting for. But there's a neat little trick you can do here with your modern digital oscilloscope to measure this anyway. Connect one channel of your oscilloscope to the hot signal and one channel to the virtual ground signal. So in this case, TP504 and TP502. Make sure that the volts per division match as well as the DC level. Now put your scope in math mode and then subtract the virtual ground from the hot signal. That way what you end up with is what you would have measured between the 2 points had you connected the machine using an isolation transformer. To reject noise, I set the bandwidth to 20 MHz and I told it to show me the peak to peak of the math envelope. It's supposed to be 28 millivolts peak to peak, but to compensate for noise and stuff, I set it for a little bit more than that. That's the chroma side done. Now as for the peak to peak voltage of the luminance side, it's supposed to have about 130 millivolts peak to peak. Compensating for noise, I figured this value of between 140 and 150 millivolts should be good. So let's record something, and not very happy with that yet. So this is the last piece of the puzzle. It's the circuit that processes the luminance signal for recording and frequency modulates it. Look at this. This adjustment is simply called dev-adj, and it's supposed to adjust something called deviation. I have no idea what that means, and this is the procedure to adjust it in the service manual. It's huge, it's a mess, you have to disconnect things and connect resistors and capacitors and whatever. I mean, it's not fun. But what this is just a voltage divider. This is the video level that goes into the FM modulator. It's a separate level control in between the two buffers here. And on top of that, they even give you a capture of the test point that follows it on how the signal is supposed to look. And this was grossly misset. Either I had messed with it before, or something changed when I changed that chip. And since we know that our E to E level is good, really what you have to do is make it look like it looks in the picture, and that's it. Like, why go through all this effort? It's supposed to be 2 volts, not 2.5. Oh, that is doing wonders, man. I think it's perfect this way now, yeah. Oh, that's much better. Oh, it works, man. It's perfect. Dude, it's perfect. Now we have one last issue remaining, which is that the tuner does not have any audio on it. And I'm gonna demonstrate this real quick. There we go. And we have just a bit of noise and nothing else. So let's look in the schematic where that comes in. Well, here's where things started going south a bit. The service manual that I purchased for this machine eons ago does not actually have the schematics for the tuner, or a block diagram, or virtually anything that would help me. Just those 2 pages are conveniently absent from the whole thing. So what could I do without a service manual? Well, first of all, in this giant rat's nest of interconnections, I managed to find the demodulator output. It goes to the little front panel thing where you select between the inputs, and I decided to see if there's any audio here. So here we have the tuner board. P703, and pin 5 of that is the audio demodulator output. I'm gonna check with my scope here. Now, I might be mistaken, but that looks like absolutely nothing. Pin 2 is demodulated video, and that's clearly there. Now, I really didn't want to dismantle the whole machine again to undo this board, and I was really lost without a schematic for it. But thankfully I don't really give up that easily. This is a service manual for a next generation machine, the NV-7800. And wouldn't you know it, it has the schematics for the TV demodulator. And I mean, it's not exactly the same, the layout is a bit different, like the board here. But the schematic is still useful because the most crucial part for us is the same, and that's this. This is the audio processing chip used in this circuit, and it's the same on the 8600. So all we have to do is see where the audio comes out of that chip, and clearly it's pin 8. So let's check pin 8 on our chip. How the hell did that happen? There you go. There's your problem. That's a 5K potentiometer. Audio level. It's gonna be hard to get that out. That's no good. Here, this potentiometer with the exact same value. It's a bit smaller than what's supposed to go in there, but that's all I have. I installed the potentiometer and the audio was working now, but still a bit dodgy. Take a listen. It's always one thing after another. I guess I gotta redo the switch now. Take it out, clean it, you know. So here's the switch disassembled before cleaning, and this is after cleaning. That's a pretty big difference. Let's see if it works. It just wouldn't be a video of mine without some recording tests, so here's some stock footage that I recorded using this machine and played back using this machine. Built in 1978 and restored in 2022. Let's see what it can do.